Hello, dear students. This is question 1.67 of the books of I.E.Erodov. The question is say that a bar of mass m is pulled by means of a thread up an inclined plane forming an angle alpha with the horizontals, and in the figure 1.13 the coefficient of friction is equal to k. Find the angle beta which the thread must form with the inclined plane for the tension of the thread to be minimum. What is it equal to? To find the value of the tension in the thread. So in these questions, first of all, we will draw the freeboard diagrams. Then we'll apply the equations of the motion. So let this is the tension T. Suppose this is a tension T on the thread, and this is block, and there is a friction force of the coefficient with a K. So in these directions, because here this is the N normal direction, and downward force is mg. This angle is alpha, so this angle also be alpha. This component of this will be the mg cos alpha, and this component is mg sin alpha. Okay, and the component of the tension will be the t sin beta in up toward the up the planes, and in the direction of the n normal direction, this is the t sin beta. Okay, so net forces on the body in this direction is n, and the t sin beta, and perpendicular and in the upward direction is mg cos alpha. Another in this direction is t sin beta, or in this direction is mg sin alpha. Okay, when body start to move upward by the action of the tension in the thread, a friction force acting in the downward direction F, and the value of this F is mu n. Okay, mu n. So in the question is given there to find the angle beta which the thread must form with the inclined plane for the tension of the thread to be minimum. So the tension in the thread should be minimum. So what will the angle of beta? Okay, beta. What will the angle beta for T minimum? For T minimum. So in the direction of the normal directions, there is no motion. So we will balance the forces n plus t sin beta is equal to the mg cos alpha. Okay. Now or in the direction of the inclined surface, first of all we will calculate the value of the n here. This is the mg cos alpha minus t sin beta. This is the equation number 1. Now second equation in the direction of the plane. In the direction of the planes, so find the angle beta which the thread must form with the inclined plane for tension of the thread to be minimum. For minimum tension, that means the sliding is just start. And sliding is just start, that means that there is no accelerations, only balance the just forces. So T sin beta force in the upward direction, and in the downward direction force is mg sin alpha plus mu n. This is second equation. First of all, we will eliminate the value of the n. So substitute the value of the n from equation 1 to in the equation 2. We will find t sin beta is equal to the mg sin alpha mg sin alpha plus mu, and this is the mg cos alpha. First of all, here we will calculate the value of the t in the column of the beta. Okay, so take the t common, t sine beta plus mu sine beta equal to the mg sine alpha plus mu mg cos alpha. Okay, so value of t is equal to the mg, taking the common here, so this becomes sine alpha plus mu cos alpha, dividing by taking the sine beta common, this is the 1 plus mu. Okay, for t minimum, when the t minimum, then the denominator should be maximum. So t minimum, that means the sine beta 1 plus mu should be maximum. Should be maximum. Okay, that means okay. There I did some mistakes because the component will be the cos here. Component will be the cos. So put the component cos. T cos beta. Okay. So every place we will put the value of T cos beta. T cos beta. So first of all, this use the second equation. T cos beta. Second equation. T cos beta. Here the beta. Here beta. Okay. So here is the beta, and everything is changing here. So T cos beta. T cos beta, and here is also beta, and this comes out to be cos beta plus mu sin beta. Okay, and here also denominator would be cos beta plus mu sin beta. This should be the maximum. So this value should be maximum. So with let y equal to the cos beta, you will minimize the cos beta plus mu sin beta. So maximize the this. So we will differentiate dy by d beta. Differentiate the y with respect to beta. Okay, so this comes out minus sin beta plus mu cos beta, and put this equal to the 0. So after solving minus sin beta plus mu cos beta equal to 0, that means the sin beta equal to the mu cos beta. So this comes out to be tan beta equal to the mu. So value of the beta will be the mu. So in the starting in the questions, what will the value of the beta? The beta will be the value of beta should be tan inverse mu. Then this is the value of the beta. So in the questions, find the angle beta which the thread must form with the inclined plane for the tension of the thread to be minimum, and what is it equal to? So what is the value of beta and also the minimum value of the t beta. So for the calculation of the t beta, we will substitute in the equation number 3 of the angle beta. So tan beta is equal to mu, then the cos beta comes out to be, we will consider say triangle is a beta perpendicular by base, so mu square plus 1. So cos beta comes out to be base upon the hypotenuse, so mu square plus 1, and the sin beta comes out to be perpendicular by the base, mu square plus 1. Okay. Now substitute this value in the equation number 3. Use equation 3. In the three equations, so t becomes mg sin alpha plus mu cos alpha. divide by the cos beta plus mu. Cos beta comes out to be cos beta, and this is 1 upon the root over mu square plus 1 plus here mu 1 mu become mu square because mu is already present in the equation number 3. This comes out. So mg sin alpha plus mu cos alpha divided by the 1 plus mu square divided by the root over mu square plus 1. Okay, so this becomes the mg sin alpha plus mu cos alpha divided by the root over 1 plus mu square. So this is the T minimum value. Okay, thank you.